It gives me great pleasure to introduce Dr. Alice Abraham. And I'm very happy to also say that she's a potential Rotarian of our club. Um, Hope that, she has already attended a couple of meetings of our club, and she has a good idea, fair idea of what we do. And she is the president of Impact Group of Institutions, a 40-year-old group of colleges in north of Bangalore, and has extensive experience in education management. As a key member of the board of the Impact Group of Institutions, Dr. Abraham has lent administrative leadership while addressing the regular operational bottlenecks. Over the last 28 years, Impact Group has achieved significant growth under her leadership and the development of impact institutions from a young institution. Dr. Abraham has a distinguished academic and glorious professional career. She is a bachelor's and master's in electrical engineering, both from UVCE, Bangalore, and a doctorate in computer networks from Bangalore University. She has also completed her MBA from IIM Bangalore, where she was the first woman president of the Students' Council of her program. Dr. Abraham had the opportunity to participate in a global program at IE School of Business, Madrid, Spain, that involved a network of 50 top-ranking global institutions. Dr. Abraham has also worked on developing an Israel-India entrepreneurship program under the aegis of Tel Aviv University, Israel and IIM Bangalore. So I can see that you've been really somebody who has been, getting people to innovate and, develop entrepreneurship in people. And that's also one of the things that Rotary does. And we call it vocational service, and we appreciate people who have achieved excellence in their vocation. At the same time, we also try to help people in their businesses and in their careers to try and develop their skills. So I'm sure you will be a great asset. As a part of her doctoral research, Dr. Abraham has published 7 papers in peer-reviewed international journals and has 6 conference papers in international conferences at Shanghai, Malaysia, Singapore, USA, etc. Currently, Dr. Abraham is engaged in establishing new age academic programs in the emerging fields of artificial intelligence, data science, robotics, and automation. Dr. Abraham is actively engaged in supporting underprivileged students pursuing professional education through UVC Foundation. And I was also associated with, organizing some programs for, the work. So I've seen firsthand the kind of work that she's involved with. An alumni trust of which she is the president and trustee. The trust has so far supported over 800 students with scholarship worth over rupees 1 crore. Awesome work, Alice. And the stage is over to you, Alice. I present to you all my dear friends and Rotary to you.
Thank you so much, Shankar. I didn't expect you to give all that out. I just gave you the biggest list I had. But I'm really privileged to be able to speak with all of you, Shankar and Bharat, our dear old friends. It's always nostalgic when we meet. And now I'm being welcomed so nicely by such a lovely group of people. I'm glad to be here, and I thank you for inviting me to share whatever I know about this new field. My perspective on this world of AI is that I have done my research in computer networks, as Shankar mentioned, and lately I'm involved in implementing a program at my own institutions. So there's a whole lot of learning involved. It's a whole new field, especially in India, an emerging and very exciting field. They also all the knowledge we gather is mostly from conferences, talks like this, and experts, exchange of opinions, partnership with institutions. So all that is what I've amalgamated and brought to you today in what I hope can give you some insight on artificial intelligence. Uh, at least I hope that after this talk, you will be able to go away with an idea and a definition of artificial intelligence and what world to look forward to, and in what way you could leverage this knowledge in whatever stage of life you are, there is definitely an opportunity to ride on this wave that's taking over the future. So I have a presentation of several slides because it's a new field. I won't be able to make it extremely interactive initially. Let me share what thoughts I have, and at the end of it, maybe we can have an interactive session, and I'll try to answer the questions you may have. So let me just put up my presentation. Okay. So this is where we are, artificial intelligence, today and tomorrow. What exactly are we looking at? What is this intelligence? And where do we fit in? Where will it take us? This is what we will look at. All of you will agree that we are at the beginning of a revolution. The age that we are in, things are changing so fundamentally and rapidly and exponentially. The way we live, the way we work, and the way we interact with each other. Just to take you back and give you a perspective of the exponential changes that we are going to see now, let's see how changes have taken place in technology and in the industry. In over the last a few centuries. So we started the first industrial revolution in the 1700s with the advent or invention of a steam engine, steam and steam power, which led to mechanized production. So we had machines. And then there came the invention of electricity. And with that, we had the second industrial revolution, which uses electric power to create now mass production, from mechanized to mass production. And then we had the computing, the third industrial revolution, which is the computing power, information technology from 60s onwards. And then there was a much greater growth in the industry, several changes. And now what we are at, what is called the fourth industrial revolution. And what does it entail? It's very difficult to define the revolution that we're going through, but digitization is a huge part of it. Our world is changing and getting more digital by the minute. We have uh, smartphones and tablets, almost in 3 billion smartphones worldwide by 2021, they say. And you have devices that are connected, things that are connected with each other. We have online commerce, the Amazons, and 450 billion is the business transaction expected by 2021. We have a huge amount of data generated because we are all connected and we are all having so much of information that is digitized. And then we are in what is called the generation C, the generation consumers. We've turned into consumers because we are so connected and we have so many needs and that are easily satisfied, and we are actually a spoiled lot because we are pampered consumers, I would say. So this ubiquitous connectivity is is huge. We also have seen that the cost function of things have come down. Just to give a comparison, we had the Apollo guidance computer in 1969, which had a 2 megahertz processor, and the small iPhone that we have now is greater than this. The presentation that I made was last year, so it was 1.4 gigahertz. I don't know the speed of the processor now. Similar, the RAM capacity has jumped manifold, the ROM capacity, the weight of these devices have come down to a fraction of what it was. So 700 times faster, greater capacity, and lower cost, much lower cost. So something very interesting is happening in the world. we have seen that the business also have started changing from what it was. The traditional business models don't exist anymore. So you have the largest taxi company, which doesn't own cars. They are a platform. The biggest media owner, Facebook, does not create its own content. The most valuable retailer has no inventory. Amazon has no inventory of its, or Alibaba doesn't have any inventory of its own. And then and Airbnb does not own a single property, no real estate, but it's the largest accommodation provider. So that's how businesses are now. They are changing, and that's because the ownership, the value is resting with the platform owner and not the inventory owner. And the way the competition is happening is also changing. Earlier, you had Penguin competing with the McGraw-Hill publishers, but now they're competing with Amazon. Same way, the movie makers, NBC, CBS, huge giants, but now they are competing with Netflix. You have the timekeepers, Swatch, Timex. Nobody wants a watch anymore. They just want the latest iPhone or the phone in their hand, which serves for a camera, which serves for a watch, and several other things. Uh, Similarly, so many changes. The competition is not what it was. And all of this is facilitated because of this exponential growth, change, availability of technology, Internet of Things, drones, you have gamification, you've got crowdsourcing, blockchain, big data, artificial intelligence, the cloud, co-creation, 3D printing. All of these new technologies, they serve to help improve experience, enhance productivity, and they create new business models. So how does it impact? Because this digitization haven't reached artificial intelligence. We are still in the digital changes that are happening in the environment. And you can see that the CAPEX, the amount of investment that businesses are doing is gravitating in a huge way towards digitization. About 25% of enterprise revenue is taken by digital attackers. Most of the incremental investment is in digital, and they adopt digital technologies, even in the smallest companies. And you have robots and artificial intelligence, which are joining the workforce. So the world is getting digital, my friends. And so this is the world that we need to look at and be prepared for. And now let's look at the topic for today, artificial intelligence. What exactly is it? What is artificial intelligence? If I ask our friends, about 15 of us who are here, I'm sure I will get 15 different answers. So we have such an idea about artificial intelligence. It's all around us. I'm sure in some manner we have been exposed, we have heard about it, we have read about it, you might even have worked with it. But with the concept being so vague, there are people who think this must be something like the science fiction movies we used to see in the 1900s, the Terminator movies and the bad guy, and that is the epitome of artificial intelligence. No, that's not what it is. And it's not, it's on the other end of the spectrum, it's not magic either. It's not like you give it huge data and it just spits out numbers. You don't know what it is. You don't know how it came, but it starts doing magic. No, that's not how it is. It is definitely a science. So it's more like this. This is an image that to me signifies what artificial intelligence, the kind of problems that artificial intelligence can solve today. This is a picture of diabetes research work where they have done research about 10,000 diabetes patients, taken data from 10,000 patients and 100 data from each of these 10,000 patients. And they've done a cluster analysis, which is a method of artificial intelligence. And they basically identified specific that there is a type 3 of diabetes. So far, most of the knowledge is that there are two types of diabetes. And but there are some doctors who say they might be, but nobody is sure. There is absolutely no confidence to confirm that there is a type 3 of and diabetes. But using this analysis, using this data, AI is able to emphatically identify that there is a type 3 diabetes. So this is the power, of artificial intelligence that will help to solve problems and questions that man would not have been able to solve before. So if you give a very simplistic definition, artificial is machine-like, and intelligence is the capacity to learn and solve problems. So AI, artificial intelligence, is the simulation of human mind by machines. These machines should be able to solve the problems. They should be able to act rationally. They should be able to act like humans. Then you say that they are artificially intelligent machines. Just to give very simple, an understanding of intelligent or a robot, what an intelligent machine can achieve. Basically, it should be able to work on its own. Now, look at this wardrobe, and it's in a disarray, and you would like the wardrobe to be arranged, and you know where the hat goes, you know where the clothes go, you know where the shoes go, and where everything is put away. But would a machine be able to solve that? But if you have a machine that's able to sort out exactly the way you would be able to do, then you would call that machine artificially intelligent. Similarly, if the same cute robot is able to serve black coffee to you and espresso to your spouse and cappuccino to your kid, then you say this robot has reasoning power, it has problem solving ability, and it is artificially intelligent. Another simple example of artificial intelligence, you have this lovely robot again, created in the lab and deployed in a new terrain. It doesn't know the place. So it has to first learn the environment, the heights, the lighting, and so on to move, to operate in that area. It has to do a certain amount of learning. And a machine first learns, and then it is able to reason. It should be able to reason. Now it's come across a road, a crossroad. Does it go right or left? To its right is a rocky road and the left is a paved road. So it has to take decisions, it has to reason. And now it comes across a problem. There's a stream and it cannot cross. So just like a human being, what do? You pick up whatever, you try to make a bridge and cross. So that's what the robot would do if it was artificially intelligent. So if it was an artificially intelligent robot, it will have problem solving ability. So these are three factors, simplistic factors that can help you define a good intelligent machine. Adapt, reason, and provide solutions. We've seen artificial intelligence all around us. It's operating, helping us, making our life better. It's there on our phones. It's there in the social media when it feeds you all the whatever you like, your sites, your the shopping that you like, and the sites that you like to visit. They just pop up in front of you. All that is because of artificial intelligence. Gamification, and then fintech in banks and insurance companies use it in a huge way to identify potential customers and high paying customers, profitable customers, and risk mitigation and so on. And then a good place to employ artificial intelligence is, of course, our chaotic traffic management and so on. Now, artificial intelligence is not like just a computer being extremely efficient. Earlier, when we talked about computers, They are, they're machines that can do faster, more efficient than man. That's a computer. That's what we traditionally learned was the beauty and efficiency, the benefit of using a computer. But now we have computers which think man-like, which respond man-like. And a good example of an adoption of artificial intelligence is our simple Google Translate. Now, if you use Google Translate about 10 years ago, which when it had just come in, it wasn't that efficient. It didn't know all the words, but it's been learning. As people ask questions, it's been learning. There's been a training, there's a live training going on, and Google picks up all the questions, matches the answers, stores it as huge memory, which is on the cloud, and uses it when somebody else asks questions. So over a period of time, just like a child learns in school, and by the time a child graduates, there's so much of knowledge he or she has acquired. A machine learns over a period of time by storing all the knowledge, all the questions, all the queries that it has got before, all the rules that have been fed to it as in its repository, and responding better and better and better. That's how, so you have this Google, which gives its initial training data for the translate. It gives some basic set of words, and you create a model. And then when the user gives an input, it uses the model. But this user, there's a feedback loop here. There's a feedback loop here, and more users use, the model gets better and better. That's how it works. I hope I am making sense. Now, this is just to show you that there is a certain learning to use artificial intelligence. Machine learning is the heart of artificial intelligence. It's a huge part in enabling artificial intelligence. And within a subset of machine learning is what's called deep learning. Deep learning is brain-like algorithms, what you call neural networks, just like our nerves. Our brain makes and breaks circuits like this. You have these synapses that make through the neurons and dendrites and transmit information. Same way, this nerve network is artificially simulated, or this is similar kind of networks are made and broken to make decisions in artificial using in neural networks. Now, artificial intelligence is not something that's happened now. It's been there for some time. It's been building up in the academia, in the research world, way back from the 50s. This is called the Turing's test, which is now modified. But back then, Turing's gave a test on how do you decide if a machine is intelligent. What he did was put a screen to to uh, to shield specimen A, which is a man, and specimen B, which is a machine. And this is the interrogator. So the interrogator asks the same questions to the machine, and the man doesn't know or who is answering. And back then it was through typing, through words, letters. So if the machine and the man's answer match, then you say the machine is intelligent. The answers need not be right, but if both of them give similar answers, then you say the machine is intelligent. So this was a basic fundamental test which holds good even today to decide if a machine is intelligent. So what constitutes AI? First of all, if you want AI to be intelligent, to create an AI, it should have some kind of human level comprehension. So you have, it needs to, just like a human being comprehends information and stores it and takes decision based on information that it already has, the machine should be able to do the same. The machine should have the ability to learn. Uh, when you say the machine should have the ability to learn, human beings, we learn basically through patterns. We recognize patterns and then we run a regression. When we're talking about computer decisions and computer programs that humans work with. So humans were traditionally those that found patterns. They ran linear relationship in data. We think more linearly. And then when they run the regression, they find out that there is some decision or some pattern. Now we want the machine also to be able to learn, to look at data. We just give it data. We should be able to give these machines a data set and say, hey, there's a pattern there. We don't know what the pattern is, but even if we don't tell them what the pattern is, it should be able to make out a pattern. That is what we called an artificially intelligent machine. And of course, of late, we have natural language processing, which is a necessity if we have to leverage AI in the real world or the broader world. The machine should be able to comprehend language, accents, mistakes, errors, just like a human being can. So the better we get at it, the machine gets at it, the more efficient the intelligence is. So let's look at a few examples of existing AI machines which are smart and progressive. So we've seen in October 2011, Siri, Apple came up with Siri, and then immediately you had Google Now, similar to Siri, answering questions in these Android phones. And then Microsoft took a few years. In 2014, it came up with Cortana. 2015, you had Alexa, and then you immediately had in 2015 Google Home, all of these answering questions. So these are examples of artificial intelligent devices, but they have their limitations. They are not what you called broad AI. They are what you call narrow AI. There are certain limited data sets that they can use and give you answers. There are several other beautiful use cases, like you have this facial recognition that Apple has already implemented in its phones and its devices. And most of these hotels are and the airports, these are early innovators. They've adopted them. You have some of the 7-star hotels, Hilton and all in the US, that uses concierges that are robots. Of course, these are double-edged swords. And then you also have the futuristic security checkpoints in airports likely to look like this. No human being there, facial recognition and terror recognition, all this is identified just by the machine. Beyond facial recognition, there came object recognition, which enabled even more. Now you had traffic lights, traffic vehicles, and you could manage vehicles. You had the Google Maps, the Google Street, and all that. And huge area of this object recognition is advanced manufacturing, where you can identify defects very efficiently. And you can even count people in a huge people gathering. Can you imagine numbering this? And then of late, you have this autonomous driving vehicles, several claims, several experiments and exercises being done to release these autonomously driven vehicles onto the road thanks to AI. Tesla was one that came up with this AI vehicles in October 2015. And then you had this Watson IoT IBM machine, which first ran in Washington, D.C. in 2016. And this Oli on the bus is manned only by the AI device. It even responds to queries. Like suppose a passenger asks, which is the best restaurant that I can stop at in the next 10 minutes, Ollie will answer, give you a good appropriate answer. So that was an interactive, AI-driven, autonomously driven electric vehicle that was actually deployed on the streets of Washington. And then they tried it out with the trucks. This truck ran 225 kilometers. This ran across the US. This was owned by Uber as a test drive with, of course, there was a human person in the vehicle, but not driving it. It was autonomously driven. And then in Europe, they had these four trucks going across the highway across 8 countries, totally autonomously driven. So this is how they do. What they do is they build these huge platforms. They give it rules, and they also tell which are the contingencies, the exceptions to the rules when you should diverge. And with the availability of this huge amount of computing power, data storage, processing power, uh, um, it is possible, and the cloud, it is possible for them to store all this in the memory and reach out to it when they want live and give a perfect response to any situation. But this also has the other side. That means these driverless cars will displace drivers in cars. And there are several other jobs that can get lost, that will get obsolete because of the advent of AI in machines. It's that easy. It's just as easy to convert these machines to AI machines, to these cars and trucks and everything to AI machines. So it's predicted. There was a study in 2013 in Oxford that said that 47% of US jobs can be replaced by AI in the next 10, 15 years. And if you can look at the number, there's also China, which says it's even higher. It's at 77%, and India is at 69%, not much lower than that. So the risk of job loss due to automation is very real. Now, what kind of jobs get lost? What are the jobs? Typically, it's these repetitive manual jobs. They will be replaced by robots. And then you have got these little more intelligent jobs, but again, repetitive, which can be replaced again by programs. So in all, 47% of US jobs are of this category, robots, algorithm. And you can expect in India, it's 69%. And now, what are the jobs that won't get replaced? It's non-repetitive jobs, jobs where there are more decision makings, more uncertainty. There's no pattern in it. Then good, efficient human beings are sufficient to do those jobs, and they're not likely to lose their jobs as easily. And of course, the creative human beings like Shankar would never lose his job because you can't have a machine to get that particular light and that particular image of uh, those camels in that sphere ever by a machine. So this is the scenario of yeah, artificial intelligence if we don't do anything about it. If we are aware of what we are and we don't change, we don't adapt, and we accept these changes, then this is the likelihood of changes in job market. Now let's look at machine learning. I hope I have not jaded you. I wanted to quickly go through, I definitely wanted to give you some idea about machine learning just to see. One moment. Huh? Girls, can you just keep quiet? Yeah, sorry, my girls, my daughters are quite active in the evening. Yeah. So machine learning is an enabler of artificial intelligence. Let me just give you an idea about machine learning through this beautiful program they created. You have, okay, we've seen that games are a microcosm of what is the real world outside. When you computer games, board games especially, they're not just mindless. Some of these games really teach you logic. Chess is one of them. So computers have traditionally tried to ape and create and compete and excel at these games. They started with the backgammon in 1992, and then there was the checkers draft game 1994. And a watershed moment was when Deep Blue defeated Gary Kasparov in 1997. This machine, IBM Deep Blue, could defeat the world champion of chess at that time. So there has been always an urge for improving and comparing and competing the machine to see the level of efficiency and superlativeness of the machine by competing with champions. So there is this game called Go. Go is a game that was created by a Chinese Chinese company, and it is much more complex, or much more intuitive than chess. Chess is a logical game. So while chess has about 20 options for each move, if you compare Go, it has 200 options for each move. And they say that basically the number of configurations that this board game can have, the possible configurations, exceed the number of atoms in the universe. So it's a very um, complex game that you can't write the rule for. For example, you have the champions, and if you ask a good Go player why he made that move, he said it just felt right. It's not by logic, it's more by intuition. So this game is what a company called DeepMind tried to recreate along with Google. Google purchased this UK company, and they decided to construct a robot called AlphaGo. AlphaGo's objective was this: to beat the world champion in Go. So this Chinese game uh, is something that, the problem is you can't give all the rules. You can't make up all the rules because there are so many permutations. There are so many possible outcomes. You can't take a bottoms up approach of writing the rules, giving the logic and making the machines and the constraints like earlier AI, the rules, constraints, memory, and the machine is ready to be deployed. So what they did was a very fascinating way in which they created this AlphaGo. They gave this machine AI 100,000 human games that had been played already in the past. And the first objective of AlphaGo was mimic human behavior. So they gave all this data, but no rules. And the idea was to mimic human behavior. After the 100,000 games were completed and the computer was able to mimic this human behavior, then they allowed the AI to play out itself, play against itself. for 30 million more games. That means that AlphaGo machine could play with another AlphaGo machine to machine game, an earlier version of the machine. But now the objective was changed. The object now was not to mimic human behavior. The new objective was to avoid past errors and to maximize the score. So during the course of this 30 million games, the computer learned on its own. And what we find is these machines actually learned differently. They learned differently from human beings. So much so that after the process was completed, how it was calculating the machines gave the answers in a very, very fantastically different manner. And that was a new learning in the area of artificial intelligence. They were no longer following human patterns, linear patterns, but developing patterns on their own. And that's the future. Another example, of course, this is when after creating AlphaGo, it created it had the game against the European champion and defeated it in 1 hour. So those are the victories. Similarly, there's a different example of how these machines learn differently from human beings. Just like I said, a child reacts very different from an adult. Similarly, these machines also do their learning in different ways. It's not the program that we gave them. They develop their own programs. When they are given a data set and they've given a white canvas, then they develop their own method of thinking. There was this other example where AI recreated, if you remember the Bose-Einstein condensate, there was this Nobel Prize 2001, B condensate, the coldest particle in outer space or India, they created by using lasers, slow down the particle to a point where it was near 0 degree Kelvin. So this took years for BE to get a particle of that property. But AI, given just the data and given access to lasers, then they were given the objective of trying to minimize the particle movement, make it colder. They could do it in 1 hour's time. But what's different is that they did it in a method very different from what the scientists had used. They developed their own machine, their own methods. The machines learned to use the lasers in a very different method. So they basically started thinking in different manners from what it was programmed. So that is what we can see in machines in the future, the intelligence going to that level. As it gets more and more intelligent, it does not mean that it's going to ape human beings. It's going to create a very different being altogether. You have this technology whiz called Ray Kurwitz, who works for Google now, and he has predicted that the machines of today will reach the point of singularity. Point of singularity is when it thinks man-like. That's the best we can aspire for. We want a machine to think like a man, think exactly what a man would do, the machine would do. Then you say you reach the point of singularity, the machine and man are the same. It's predicted that we will eventually reach there, but it will be about 2045 by the time that happens. So this, to sum it up, this is the scale, this is the curve of changes of the industry over the last few centuries. From 1900s, if you can see, the growth has been pretty linear, but then now it will be extremely exponential growth that we have till the point of singularity, when we have man-like machines. I, so to sum it all, artificial intelligence is a concept, a science where we are trying to create machines that behave man-like, independently learning itself through experience with minimal interference from man. So there will be changes in the world. There will be a lot of changes in the jobs, but that does not mean that there won't be any jobs for us, because it's just that the jobs as they exist today will not exist tomorrow. Many of these, as I said, repetitive manual jobs are replaceable, will be replaced by better machines. But there are great other jobs that can arise because of the growth of AI. You have several new emerging fields. Unfortunately, I did not bring that slide on this. I missed. But there are beautiful new areas that are coming. So whatever phase of life we are in, now I can see that we are all of the same generation. We are in our 50s and 60s and 40s, perhaps, in this Zoom meet. Do we have a place in this? Do we have a participation? Does it mean anything for us? Well, it depends on where we are headed, what we would like to do. If we want to be actively, professionally involved, technologically involved, we want to leverage it for our business, or we want to use it just for making life better, making things more comfortable around us. Definitely, we can leverage artificial intelligence in several ways in our lives. Thank you so much. So I think all of us, this is a slide that I put to my students because I would like them to think about the future. The future belongs to those who prepare for it today. Indeed, all of us can do that. Let's know what the future holds, and let's also proactively prepare for it. Thank you so much.
Thank you, Alice. Now, actually, the floor will be open for questions. So I think it was a wonderful talk, and the slides were really very interesting. And it gave us a quite bird's eye view of the whole situation. I think Sundar has already raised his hand. Yeah, before Sundar, I would just like to there is a couple of questions, but I'll just ask one for now. Would you say that mentally and psychologically are humans evolving as fast as the technology is evolving? And if not, if we are not keeping pace mentally and psychologically, what would you say would be the pitfalls? Apart from job losses, there might be other kinds of jobs created, but what are the other pitfalls? One of them could be that we are not mentally and psychologically evolving as fast as the machines are.
See, I think that's a wonderful question, and it begs an answer from a psychologist rather than just someone who is in AI or technology. Uh, Human beings are a very diverse lot. So there's no, one path. Everybody does not reach the same path at the same time. It's a pretty unequal world. But having said that, the kind of demography that we belong to, uh, I think we are okay. We are all at the same level somewhat, except you have companies like Google and Apple. They're all on the cutting edge, but otherwise rest of us are on the same level. Definitely technology will be several steps ahead. It will always be like that. It's for us to seek out and use it to let's not become slaves to it. It's not necessary for us to fit in and utilize everything that is there, but understand, know the pitfalls and the benefits of these new technologies, and try to use it. Let's not feel insecure that we are way behind, nor that it's something that needs to be feared. That's what I would say.
So thank you. Sundar, you had a question?
Yeah, hello, Dr. Alice. Wonderful, awesome presentation. This is part of my subject in my career, which I work on. I have been supplier to ISRO for the satellites. I specialize in power systems in the satellite. We already adopted Industry 4.0 in most of our batteries and solar panels to closely align with the ML, AI, etc. So a quick point is I've been an adjunct faculty of BITS Pilani. I'm a student of Pilani BITS. I just want to know, because I'm getting old, so my skills in programming is going backwards. So I do recommend, talk to students on and off. Currently, students are exposed to C, C++, Java, JavaScript, Python, R, etc. Are these enough for the students to tackle AI, ML, DL, or they need to learn more?
They need to learn more, because these are just the ABC of the new languages that are coming up and the new technologies that are there. You have to learn, first of all, there are these cloud computing. So one needs to learn AWS and such proprietary knowledge, because they're going to hold the world to ransom if you're not part of it. So AWS for the platform, and then depending on if you're using data science, R, and there are some other programming languages that use there are new learnings required beyond Python, and so on. There's several other security. If you're looking at security, then there are certain languages proprietary to that. So you need to get into it. Maybe we can, what we have done at our institution is we have partnered with Amazon, and we have taken it as a course to train the students on AWS, because that is the cloud platform. That's where it all rests. And the wonderful thing was, once we signed on with AWS, they opened up several training programs, which even I don't know, because there are huge options. It depends on which field the student wants to go. If he wants to go to data science, then there's specialization in training and so on for just that field. And if it's security, then there's training in that field and so on. So if you are interested, you can look at AWS training. A lot of training programs are there. And Udemy, just look at cloud computing and such things, which will help you further.
Dr. Alice, wonderful. Thank you. And one on the lighter side, one small question, if you don't mind.
Yeah.
You said that, manual jobs can be replaced going forward in the next couple of years.
Yeah.
So the first manual job I see is the wife's cooking. So that can be replaced by a robot.
Is the? Sorry,
the better half's cooking in the house, which is a proprietary.
That's a very creative
can be
field.
replaced.
Not at all. Not at all. Just you try it.
I know I will be fasting after that.
No, but one thing is it may be manual, but it's not repetitive. It's very creative. You won't have the same dish 2 days in a row. No machine can repeat that. So if you eat a machine-made dish, you'll be fed up. So
no, that's what your next part of the slide said. Repetitive algorithm will take care. So that can be taken care. Shankar is going to second me for that.
Shankar has a question.
Yeah, Alice, I was coming from more from a Rotary perspective here. I mean, from a social perspective. So if people are going to be losing jobs, how can we prepare the youth to be more, let's say, current and relevant? And on the other hand, how can we equip the youth to ride the artificial intelligence wave? So, because I understand, because I work for the university as well, I know how much lag there is between the university and the reality.
Yeah.
Yeah. So how does one prepare the youth? There are two questions here. One is, how do we prepare people to be more current? I mean, those who are not involved in computers or anything like that, because people who are involved in repetitive jobs are going to get involved in repetitive jobs. And the second thing is about the university. How does the universities ramp up to ride the artificial intelligence wave?
See, the two parts of these questions. One is those who are in the digital wave, those who are in the knowledge, who are working in the technology area, and those who would like to be part of it. They don't want to miss the, wave and be left out. So even if they are not the programmers or the learners of this technology. So let me take up the second part, that is those who are not in this. Uh, it's always good to be informed. It's always good to know what new is happening. And there will definitely be areas of interest for everyone. It's not like you only have technologists who will live in this world. There will be non-technologists also. So if it is for example, yourself as a creative person, I'm sure you can leverage, you can see that there's going to be an additional tool available to you to enhance your creativity. Know what it is, be
Yeah,
informed.
like in Photoshop now, we can remove the background. We can make somebody fairer, somebody somebody thinner. So normally, whenever we get a request from people, they always say that to make me more better than what I am.
I'm going
So,
to send you my pictures soon. I didn't know you could do all that.
so the latest Adobe Photoshop can actually, for example, you have a background which you don't like, you can just remove the background in one shot. Otherwise, we have to do 20 clicks to do that. Now we could do it in one shot.
Yeah. It's just know where the world is going, be informed, and don't be ignorant of it, and leverage it. Otherwise, use these new tools to make your life more comfortable. It's either you buy the comfort that AI provides, or you create the comfort that AI provides. Right? So be a consumer and somebody who can enjoy AI and be part of it. Be informed. Don't be shy of learning new things. Uh, and the second part is, what does the industry, what will the university, and what program should somebody who wants to be part of it? There's always a lag in any university curriculum, because by the time it's developed and implemented, the research has gone far ahead. The industry has also gone ahead. So the farthest is the research is always 4 steps ahead of what happens in the industry, and the industry is 2 steps ahead of what happens in the university. So for any good student, it will be they must also be part of the research community. They must be part of the new knowledge that's there. There's so much of knowledge out there available to us at the click of a button. So an inquisitive mind, somebody who's hungry to learn and who's focused on these areas, should also have one foot in the industry, one foot in the research area, one foot in the industry, and then just float around in the university. That's what I would say. These are the places that you learn: research and the industry.
Thank you, Alice.
Okay. Yeah. Next question. Professor Ishwaran. Yeah. Professor Ishwaran.
Yes, thank you. Well, it has been a wonderful presentation. I learned quite a lot about it myself. But as I see that there is tremendous application of AI in the biomedical engineering and discovery of new drugs, with all these large amount of data and machine or deep learning so on. Do you think there will be quite a bit of interest now in the virus which we now see, the COVID virus, which has got tremendous mutated forms and so on, and large amount of data is being
Absolutely, absolutely. As just as we speak,
be
it's
quite a lot of
the
work.
research is huge.
Pardon?
There's a huge investment in research in these areas now that the virus is here and seen by all of us. In the past 1 year, there were several beautiful conferences, and I had the opportunity to listen to a speaker from University of Texas, who was on the cutting edge. He was already had identified several areas for using technology and artificial intelligence to identify genome science and all that. I can't. It happened about 8 months back, but there's huge attention, a lot of money being spent on research in the biomedical area. AI is. These are all interdisciplinary areas. Now these boundaries are not technology and bioscience and all that, like all of you would know. Everything works with each other. Even creative arts work with biology and technology, product design. All of these things work with each other. Definitely there's huge attention on the virus, and technology is working. And there's another startup that one of my friends has successfully created a machine that uses AI to sanitize a hospital room. So using AI and UV, it knows exactly where the germs are. Using sensors, it knows exactly which are the problem areas in that particular room, and sanitizes it to the level of 99.9%. So a lot of work happening.
Yeah, thank you, Alice, for this one. Next question. Does anybody have another question? Okay, so I'll ask another question now. Meanwhile, others can think about. Alice, how much time do you have?
I'm okay, but
Okay.
what about you? You have a schedule?
Yeah, up to another 10-15 minutes should be fine, I think, for most people.
Yeah.
Yeah. So normally we conclude between 8:45 and 9.
Yeah.
So we have another 10-15 minutes, not an issue. So my next question would be, if there are two, you were talking about the Chinese game, for example, I forgot the name of the game.
AlphaGo.
Yeah. So suppose there are two, you said two machines played against each other and so on.
Yeah.
So I have a question. If two identical machines are manufactured, do they both learn in exactly the same way and behave the same way, or they learn differently? I mean,
well, the experiment that they conducted for these 30,000 these games was with the machine was one was lesser, one was a previous machine. So
okay.
both were not of the same level, but I don't think they all learn independently. I don't think I would not have the answer because it has to be tested out, but they don't think alike. But that's the beauty of intelligence, reasoning,
reasoning,
logic. It's not it's by intuition.
Okay, so because if the machines have really become very intelligent, they probably should be able to think differently, though they are made identically, right? Which is not like a traditional machine.
Yes.
A traditional machine, two machines would behave exactly the same.
Throw up the same moves, same answers.
Yeah, same answers and so on.
Yeah.
Okay, so anybody has a question?
I think one final question from me, Alice.
Yeah.
When will Google Home understand all our accents?
Yes. It is still a learning algorithm. So
because I ask it to play Lata Mangeshkar, it will play Asha Bhosle.
I can't understand what you say. Yeah, sure. It still has to learn. That's something. I early on when I saw all these new technologies coming, and you had machines talking to each other and developing their own language. It was a little scary. When they so we are in a world where it's not there yet. There's definitely it can be misused, because the strength, the capacity is superlative. It's something that cannot be reined in once you have machines that learn and learn. So how do you regulate this? And the sad part is, no country, no system develops its regulatory mechanism in time, or in sync with technology. Technology always goes ahead. So there is a chance that this can be misused unless these checks and balances are there. So let's just be a little happy that the Googles don't understand us so well, and they're not as efficient, because let the governments and the regulatory agencies catch up and regulate these machines before they become monsters.
That
Yeah.
reminds me of checks and balances. That means our money in the bank is not so safe then.
Yes. You may see so many frauds coming using
So if it's artificial
phishing,
intelligence, it can just
phishing.
use permutation and combination and
Yo,
swipe your money.
Bitcoins being stolen. Can you imagine? Cryptography and bitcoins being stolen. It's not something virtual is being stolen. So you have people of that kind also.
So
Dr.
I think,
Alice,
yeah,
I
go
have
on, Sundar. Yeah,
one
yeah, go
more
on.
question. You mentioned that your organization is encouraging or tied up with Amazon Web Services, AWS.
Yeah.
Now, if you look at the web services across the world, a couple of others are 4 or 5 are in the US. Then you have Alibaba in China. There's nobody else who are famous in web services.
Yeah.
So
Azure.
don't you, and you also commented that security issue and all these issues. So totally it is controlled by Americans on one side, China on the other side. We can get trapped in between.
Yeah, we can. Yeah, that's why platform is. They own most of the memory, the data storage. They're sitting on a pretty spot. They know the patterns before anybody else knows. So how they use it, God knows. But definitely, we need a lot of ethics in this world to stay safe and happy. There,
Yeah, doctor, one more thing. Currently, we believe the Americans,
Hmm.
not the Chinese. So we can be trapped.
Oh, we never believe anybody, sir. That's what I would say. Trust but verify. Never be too sure that somebody is so safe. We
Thank
also
you,
had
doctor.
Trumps. Yeah.
Yeah,
Thank you so much.
I had one last. Yeah, Hegde sir, tell me.
Yeah. This is a very layman's question. Whether this artificial intelligence is developed only by software development, or is it a combination of software and hardware? In the sense, how a hardware can be developed with artificial intelligence.
See, now the beauty is the hardware has become smaller and smaller. You have laptops that don't have memory anymore. The memory is in the cloud. So the systems have moved in such a way that hardware devices are developed to have greater processing power. Processing powers are increasing. So hardware is a great direct contributor to any improvement in technology. So hardware is there, but at the same time, it's the software that is enabling this. This is the software that is seeing so many changes, resting on this hardware. Data storage, data processing, and data availability. Now you can buy data. There are so many people selling data. It's so cheaply available, so ubiquitous. From everywhere you get data. So data is the lifeblood of all this. It's using data that they learn, and it's available very cheaply nowadays. So all of this enables AI.
Okay, yeah. So any more questions, or shall I conclude with one question? Okay, so I don't know if it's really relevant, but we were talking about artificial intelligence, and then we're talking about, I think sometime back you were talking about the technology gap, I mean, the learning gap between the universities and, the research is 5 steps ahead and industry is 2 steps ahead. I'm told that this gap is increasing. Okay. So now my children are saying that there is no point really going for higher studies. They may as well get into industry or get into work experience straight away after a basic degree. They're saying what they're learning in college is really quite irrelevant and so on. So it's more of, I tell them at least to get married, you need some degrees on the lighter side. But anyway, so what would you say to, because you yourself are running institutions and you're also highly qualified. So what would you say to especially in the Indian scenario, where the gap seems to be widening between what the colleges are teaching and what is actually going on in the technological world?
Yeah, now, things will change over the next decade, definitely in education also. The new education policy that the government has brought out is definitely indicative of that. If any of you have gone through it or heard about it, it enables people to exit at different points in your course, in your studies. So you can exit after 8th grade or 10th grade or 11th grade or 12th grade or after first year engineering, and then go work, come back, join second year, go work, come back, join fifth, fourth, the third year, and so on. So there are many, the fundamental reason they're enabling this is because there are jobs that need people who are employable, who have the knowledge, who have the skills. So while your child will need degrees, if it's in the Indian scenario, we still value it. It depends on what your priority is. If your priority is degree, if you're a traditional conservative person, and most of us Indians are, I myself am, so degree is a necessity. But while you earn the degree, you must make sure that you get this knowledge in place through these extra certifications. They are the ones that will give you that cutting edge, because technology is ahead. So if your child is pursuing an engineering course with a university, that's just hygiene factor. That's just to satisfy the family, the marriage market, and any employer. But otherwise, to really get employed, you need the knowledge, and those knowledge you need to get it from these courses, by building things, by doing things yourself, and actually having the skill. Any employer needs only the skill, and it's going to change in the future, but not totally so. At the same time, there is a saturation. There's a point when you say, okay, this person has this knowledge because he has done a 4-year degree of this program, plus he has these certifications. I hope I've answered you.
Yeah.